Good day. I am Brian Lewis and I'm an instructor with J10S. And today, our monthly safety meeting is going to be or cover trenching and excavation safety. So, as we talk about this today, keep in mind that you as utility workers are exposed to the hazards of trenching and excavation an awful lot. So, please keep that in mind, please pay attention, and let's see what we can do to keep each other safe. Having said that, at J10S, we like to start out every meeting by talking about near misses and accidents. Gives us a chance to make any kind of corrective actions that we need to make. So, having said that, go ahead and pause the video now and talk about any near misses and accidents that you've had. And then when you're finished, start the video back again and we'll continue with our monthly safety meeting. Hopefully, you didn't have a whole lot of near misses or accidents to talk about, and we'll move right on into our monthly safety meeting where we're going to be talking about trenching excavation safety and reviewing the hazards and the things we need to do to keep everyone safe when they're around trenching and excavations. A lot of times, trenching and the safety around trenching seems like a military operation. So, what do we mean by a military operation? Well, a lot of times in military operations, the infantry and people that are going to do the fighting, they know it's dangerous. And they put that danger in the back of their minds because they have a job to do. And in utility work, there's a lot of that goes on. Trenching and excavations are dangerous. You have to make trenches and excavations to get to the pipes, to get to the lines, to do what needs to be done, whether you're putting in a new service or you're repairing an old line. So a lot of times we know it's dangerous, but we just put that type of feeling or that danger in the back of our mind. We also hurry up. We want to get there. We want to get the job done. We want to get it finished. We want to do it right, and you want to move on. I think that's normal human. That's just being a normal human to want to get things done correctly, get them done quickly, and move on, especially when you're talking about something that has a potential to be dangerous or even life-threatening. Once in a while, we have to wait. Have to wait for the backhoe operator or the track hoe operator to correctly slope the sides before we can get into the trench. Sometimes you have to wait on the trench box to get there. And once the trench box is there, it has to be put into the trench or the hole, and then you need to backfill to keep the trench box from moving if there's a potential collapse. All this means that we run out there as fast as we can to get the job done as quickly as we can, but we end up waiting if we're going to do it right and do it safely. So keep those things in mind. Some things we need to know is how to approach a trench, what to look for when you approach it. This is important because a lot of people have been hurt or even killed because they were on the outside of the trench when a trench collapsed and they went into the trench and was covered with dirt. So keep that in mind. That's not something you want to see. It's not something you want to happen to you or any of your coworkers. So we're going to talk about that. We're going to talk about what to look for as you approach a trench, what to look for, and how to keep yourself safe even when you're on the outside of the trench looking down into the trench where people are working. All right? What does a collapse mean? What does it mean when a trench collapses? How do they collapse? We'll talk about two broad categories of collapse. We'll talk about those things and why to look for them. We'll talk about how do you protect yourself, which is important. Like I've already said, a lot of people have been hurt that were not in the trench, but were standing on the side, looking down into the trench. Those people are at risk just like the people that are in the trench doing the work. Who's responsible? Well, it's really easy for us to say that the competent person is responsible, but reality is we're all responsible. You're responsible for yourself, and you're responsible for the person next to you. And this is really important. It's a really an important safety concept, that we're responsible for each other. This is good safety and health culture, and it's something that we ought to put into practice. So, having said that, when you approach a trench, you really want to approach it at a 45-degree angle, or from the corner of the long and the short side of the trench. There's going to be a few reasons why we do this, or at least two reasons. One reason is this is the most strength you're going to have in the earth beneath your feet. So this is where the dirt's going to be the most cohesive, and this is going to give you the most stability, right? It's going to give you the most stability. If you cannot approach from a 45-degree angle, or the corner of the long side and the short side of the trench, the next best way to approach is the short side. Having said this, short sides of the trench collapse all the time. Just because rule of thumb is it's a little bit safer direction to approach from than the long side doesn't mean it's completely safe. So keep in mind the safest way is to approach from a 45-degree angle, where the long side and the short side walls of the trench meet. Or if you can't do that, the next safest, although not completely safe, is to approach from the short side. Keep that in mind. That's what we want to do. So if you look at this diagram, you'll see where the corners are typically the strongest point of the trench, the strongest point of the trench walls. And hopefully you can see from the diagram that there is quite a bit of earth beneath your feet when you approach this way. When you approach this way, it gives not only is the ground more stable, but it gives you a really good vantage point to look for horizontal and vertical cracks, which we're going to talk about a little bit more as we go through this presentation. So, two reasons to approach from the corner. One, it's where the ground is most stable, and that's important. Two, it gives you a good vantage point to look for, one, horizontal cracks, and two, vertical cracks. These are all important. Now, even though I talked about approaching from a 45-degree angle to a corner, please look at this diagram, because once in a while you have to make L's, you have to make T's in your trenches, and typically when you look at the arrow, these corners at the L's and the T's are the most unsafe place to be when standing next to a trench. As you can see by the diagram, what typically happens is you only have one quadrant underneath your feet, if you approach a trench from this location, that's stable. And it's not really stable, because what happens if you pay attention, anytime there's a corner exposed like this in a trench, whether it be from a T or an L, there's usually a partial collapse that happens right there at that corner. Almost never do those corners from a T or an L in a trench stay cohesive. Most of the time they go ahead and there's a partial collapse. And you may be sitting there thinking, well, it's not really a collapse. There's just some dirt that rolls off the top of it because it's unstable. Well, even that is considered a partial collapse. So keep that in mind. It's a partial collapse or the start of a collapse. These are weak points right here, typically L's and T's. So, as I said before, when you approach from a 45 or where the long side and the short side of the trench walls connect, it gives you a good vantage point to see if either or both horizontal or vertical cracks have formed. So horizontal and vertical cracks are a big deal, and we'll see why they're a big deal, right? So as you approach the trench or the excavation, you want to start looking for cracks in the Earth's horizontal surface. Look for cracks in the Earth's horizontal surface. This is really important to do. Rule of thumb, you want to look for horizontal cracks approximately 1/2 to 3/4 of the distance of the height of the wall. So, if the trench is 10 feet deep, somewhere between 5 and 7.5 feet back from the wall of the trench on the ground is where you're going to most likely see horizontal cracks form. Now, this isn't absolute, okay? Cracks can form much closer or a little bit further back. We're talking about rule of thumb and what typically happens here. So pay attention for horizontal cracks all around, but you want to pay particular attention to half the distance of the depth of the trench to 3/4 of the distance of the depth of the trench back. So, like I said in my example, if the trench is 10 feet deep, you want to start looking for horizontal cracks 5 to 7.5 feet back. Keep that in mind. So as you get closer to the trench and as you've been looking for horizontal cracks, once you can see inside the trench, you want to look for cracks in the trench's vertical walls. These form a lot of times they form as a result of vibration, whether there's been some kind of traffic nearby that's caused vibration, whether someone's been using a jackhammer nearby, or there's construction going on, or heavy equipment, whatever it may be. A lot of times you have vertical cracks form, and they are a result of vibration near the trench. Keep that in mind. What do horizontal cracks mean? Well, horizontal cracks mean the cohesion is weak and a collapse is imminent. If you see horizontal cracks forming as you walk up to a trench, you need to start telling people to get out. You need to tell them to get out quick because a collapse is imminent. Same thing with the vertical cracks in the walls, but horizontal cracks, absolutely. Because what's about to happen is that it means that there's a pivot point has developed either at the bottom of the trench, it's called the toe, or somewhere just a little up from the bottom of the side. And what happens is when those horizontal cracks form, that means this big wedge of dirt is about to pivot away from the earth and into the trench. Pivot away from the earth and into the trench. So keep that in mind. The reason they call it the toe, the reason we talk about pivot points when we talk about horizontal cracks as you approach a trench, it really means that as that crack forms, it's about to let go and all that dirt is going to pivot into the trench. Of course, if you're standing on the side of the trench wall, you're going to go into the trench. If you're already in the trench, it's coming down on top of you. And so keep those things in mind. It's a bad situation. It's a lot of dirt, and it's going to get you stuck in there, and that's not a good thing. It's not a good thing. A vertical crack means the side of the trench is about to, quote, slough off and slide into the trench. Now, typically, this is not as much dirt as with a horizontal crack and a big piece of dirt pivoting and falling into it, but it is still dangerous. It still can kill people. It still can maim and hurt people. And you can go into the trench as this side sloughs off, just like you could, and get hurt just like you could if you were in the trench and it fell on top of you. So this is why you look for horizontal cracks as you approach. It's why you look for vertical cracks once you get there and you can see the inside of the trench walls. So keep that in mind. Something to remind you of, and I know you probably hear a lot of people quote all these figures to you, but a cubic yard of dirt can weigh between 2,000 and 3,000 pounds. It just depends on how much sand, clay, gravel, what the makeup of the dirt is in the part of the world you're digging in. Sometimes you can find more clay, sometimes you find more sand. Here in Tennessee, with the three sections that we have, East Tennessee, Middle Tennessee, and West Tennessee, you're going to find a combination of all of this, a combination of all of it: rock, clay, sand. And however it's made up is going to have a lot to do with how cohesive the soil is and how stable it is. So, how cohesive it is, how stable it is, and how much it weighs. So that's a pretty important thing to keep in mind. So another thing to keep in mind is that 24 inches of soil on a person's chest weighs approximately 1,000 pounds. All right, 24 inches of soil on a person's chest weighs roughly 1,000 pounds. And you're going to have a hard time breathing with 1,000 pounds sitting on your chest. The diaphragm at below your rib cage, that's the muscle you use to send air out of your lungs and breathe air in. It's just not going to be strong enough to move 1,000 pounds. It's going to compress once you leave your last breath, and you're not going to be able to take in any more air after that. 18 inches of soil covering a person's body, there again, weighs between 1,800 or 2,000 to 3,000 pounds. Depends on how much gravel, how much rock, how much clay, all those different components that make up dirt. Somewhere between 1,800 and 3,000 pounds. 1.5 feet of soil over your head, you are not going to breathe. Keep that in mind. Your pulmonary cavity just cannot lift that much weight for you to breathe. So guess what? You don't breathe. And if you don't breathe, you're not long for this world. It's just the cold, hard facts of it. I wish it wasn't the cold, hard facts, but it is. And that's why we have to be vigilant when we approach these trenches. It's why we need to pay attention to horizontal cracks in the surface and vertical cracks of the trench walls. Pay attention, know the signs that when a trench collapse is imminent, and take actions and warn people and do the things we need to do to keep people safe. It's also why we slope the sides of the trench back. It's why we also use trench boxes. It's why you have access to a ladder every 25 feet. All these are important. They're just important to keep yourself safe while you're in the trench working, or if you're not in the trench, if you're on the side of the trench. Most of the time we slope the sides. So if you're in stable rock, you can have sides almost, really vertical, 90 degrees up and down. The trouble is, very rarely are you going to be in stable rock. Very rarely are you going to be in stable rock. So keep that in mind. Now, Class A soil, you can have a slope of 53 degrees, which is still a pretty good slope. It's not vertical, but it's still a pretty decent angle. Pretty steep. Now, if you have Class B soil, you can have it at a 1-to-1 or a 45-degree slope. And even a 45-degree slope can be pretty daunting. But you typically have a lot of clay there. It's not been previously disturbed, and you can do some visual and mechanical tests. Use a pocket penetrometer. You can define how cohesive the soil is, and you can move on from there. Now, Class C soil is typically what most people dig in. In fact, most utilities just go ahead and assume that they're digging in Class C soil. Now, Class C soil is defined as Class C because it's already been previously disturbed, which if there are pipes in the ground, lines in the ground, somebody had to dig there and put them in. So almost always when you're doing repairs, it's going to be Class C soil. Also, contractors dig, move dirt around, things like that. So even in a lot of occasions when you're putting in new lines, it's going to be Class C soil. And just to be honest, I have not really seen anything but Class C soil in Tennessee. So keep that in mind. Like I said, most people assume it's Class C soil, and so more than likely you're going to be sloping or benching, if those are the techniques you're going to use, right around 34 degrees. So sometimes it's just not possible to slope or bench. You don't have any room. You're right beside pavement or blacktop, or you're next to a building. So if you're going to do that, you typically have to use a box or a shield. So if you do, you do. It's a very viable way to protect yourself. Make sure it's in good shape. Look it over. Make sure you have the engineering information with you. If you do have some tears in some of the walls, contact the manufacturer. A lot of times, if the tear's not at a critical part of the protective system, it's no big deal, and the company will tell you go ahead and use it. It's not critical. Sometimes if there's a tear in the side of the shield or the box, it is at a critical structural part of the box, and they'll tell you what you have to do to repair it. So keep those things in mind. Always look over your trench box. Always make sure it's in good shape. Go ahead and make use of those things. I know there's a lot of times I've gone up on site and people have had a trench box sitting over there on site just so people won't bother them. But then there's people in 5 foot of deep trench with a perfectly good trench box, and they're not using it. So don't be those people. Don't be those people. You've got a tool there, use it. Keep that in mind. Make sure your trench box is in good shape. Put it in the ditch, put it in the hole, backfill beside it so if there's a partial collapse, it won't move the box. Do all those things correctly. Make sure your ladders that you use to access the trench are inside of the trench box. That's another thing, another common thing that people do that can cause problems. So make sure it's in good shape. Make sure you've got your engineering information with you. Make sure you use it correctly. So, as I've said throughout this presentation, we are all responsible for ourselves, and we're all responsible for our co-workers. It's not just the job of the competent person on site to keep everyone safe. Yes, technically the competent person has to do an inspection after all the weather events and after any other kind of hazard or weather condition has potentially made the trench unstable or unsafe. But we all have skin in the game, so to speak. We all have skin in the game, and we should all pay attention and try and keep people safe on the job sites, right? I appreciate you all paying attention during the video. We always ask if there's any questions. So at this time, I'm going to encourage you, if you have any questions, to go ahead and stop the video and talk amongst yourselves. Try to answer your questions amongst yourselves. As you've heard me say before, all of us adults, we tend to learn from each other's experiences, and so use that to your advantage. If you got questions, maybe there's somebody there that's got a lot of knowledge you've not tapped into, and those are good people to figure things out with. If that's not the case, go ahead and talk to your safety director, your safety manager, and see if they can help you out. Of course, you can always contact us at J10S, and we're more than happy to answer any of your questions. Even if we don't know the answer to your questions, we will do some research. We will find an answer to your questions. And so that is also a resource we encourage you to make use of. I hope all goes well. I hope you all stay safe. Look forward to seeing you again in person. Have a good day. Bye.